Right. In this class, we'll see the addressing modes of the 8086 microprocessor. Right. So this one is the one of the important concept. Uh, Modes of 8086 microprocessor. Right. So what are the addressing modes are there generally? Alright, so one is the immediate addressing mode, second one is the direct addressing mode, alright, third one is the register addressing mode, alright, register indirect addressing mode, right, fifth one is the relative register addressing mode, right, third one is the base indexed, right, seventh one is the relative based indexed addressing mode, right. So like that, another two are there, intersegment and intrasegment. So by this time we need to discuss this particular seven addressing mode. First one is what? Immediate addressing mode, the direct addressing mode, register addressing mode, register indirect addressing mode, relative register addressing mode, based indexed addressing mode, relative based indexed addressing mode. Right. So in the similar way, relative based relative indexed addressing modes are also there. Right. Once you understand these things, remaining all you understand very clearly. Right. See, what is addressing mode? Normally, what is the addressing mode? So where this particular addressing mode concept is coming to the picture while performing any operation by using the microprocessor. For example, this is the microprocessor is there, right? So what microprocessor has to perform? Microprocessor has to perform. It has to read the data from the that means code from the external memory, right? It has to read code as well as data, right? Sometimes it has to read data from the IO device also, depending upon the instruction, right? Depending upon the instruction, which is going to be read from the external memory, right? It is going to be read code from the external memory while executing the program and decoding it internally in the microprocessor. After decoding, right, if processor want data from the memory, it is going to be read the data from the memory, performing some operation internal to the microprocessor, and then result is going to be out and going to be right into memory or out into the external device. The similar way, while executing the instruction, if data required from the input device, it is going to be execute, or it is going to be read data from the input device and performing some operation based on the instruction. Then it is outing the data to the output device, or it's going to be stored in the external memory, right? So from this concept, what you understand, processor always going to be execute the program, right, by taking the data from the memory or by taking the data from the input device, performing some operation, then we are going to get some result. That result going to be stored in the memory, or it's going to be out to the output device, right? This is the thing is going to takes place. Whatever the code you write, whatever the program you write, what program has to perform, whatever the instructions are there, you write program here, instructions, some set of instruction. This is going to become the program, right? So it is going to be read first code, decoding it, executing it, then second code, decoding it, executing it, third code, it's decoding it, executing it, right? So in this process, every time processor is going to perform taking the data from the memory or input device and executing the particular instruction and outing the data to the output device or going to store in the memory. This is the simple operation is going to be taken care by the microprocessor, right? But it is going to be read one by one code and it is going to be executed, right? So one by one code means what? One by one instruction. First, for example, if this instruction is read, first instruction it's reading, right? It has some instruction. it has a some instruction. For example, I written like this: move AX comma 5050H. This is the instruction, for example. Right. So in the similar way, we have different instruction. For second instruction, maybe something, and third instruction, maybe something. Right. Like that, some different instructions are there. For example, move AX comma BX, something like that. For example, move AX comma something 5000H. Right. 5000H. Like that, it has some set of instruction. It has some set of instruction. Right. If you look into the every instruction. Right. See here, these are the operands. Right. This is the opcode. These are the operands. Right. This is the opcode. These are the operands. This is the opcode. Right. What operation has to perform on this particular operands is going to decide by the what opcode you have. Right. So this move operation has to perform on this particular operand. This is the source operand. This is the destination operand. Right. This source data will move to the destination. Here the data present in this source register will move to the destination. Right. In the similar way, the data here will move to the destination. Right. So here for the data, for the source data in every instruction, if you look at this particular all instruction, right, for every instruction, source data is how it is addressing microprocessor to perform this particular move operation. How microprocessor is addressing for the source data will tell you that particular mode of addressing. Right. Based on the addressing, it's going to name its immediate addressing mode or direct addressing mode, register addressing mode, or registered indirect addressing mode. That means what? How it is processor is pointing location to get the source data, or how it's accessing, or you can say that how it is accessing source data to perform particular operation is going to tell you the mode of addressing. Right. How source data is accessing for every instruction. Right. It's immediately accessing in the instruction itself, or it's directly, or in the register. By register is pointing towards the register to access the source data. Right. Like that. We'll see one by one instruction how it is going to be takes place now. This particular operations. Right. One by one instruction we will see now. Right. The first instruction we have seen is right immediate addressing mode. One example for the immediate addressing mode. First one is immediate addressing mode. Addressing mode. Example, if you consider, right, move AX comma 5000H. Alright, this is the instruction is going to be executed by the processor. For example, here source data, if you look at this how this particular operation is going to take place. Move source data to the destination. So right, for example, for the source data, processor need to access no need to access any register or any external memory location. What normally processor while executing this particular instruction, it may get data from the external memory location or from the input device. Right, while executing this instruction to perform this particular move operation from the source to destination, right, while executing this instruction for the source data, it no need to move to the any internal register or to the any memory location which we have in external memory or any output device, any input device. Right, it's not no need to look or no need to access while executing this particular instruction by the microprocessor towards the any internal register or towards the any external register in the external memory or towards the any input device to execute this particular instruction. Where this instruction is going to be executed? In the microprocessor itself. While decoding this particular instruction, right? To move the data from the source to destination, processor no need to look into the internal register, or no need to look into the, no need to access the external memory location, or no need to access the input device, right? Directly 5000 will move to the internal AX register. Internal AX register. After execution of this particular instruction, AX register is going to be filled with 5000H, even though it has some other data in a, before executing this particular instruction. In the similar way, for example, add AX comma 5000H, another instruction. For example, this instruction it want to execute. What will happen? You already know that this instruction, how it is going to happen. AX plus 5000 and result is going to be stored in the AX, right? So before execution of this instruction, for example, AX has a 001H, 001H, right? After execution of this instruction, what will happen? This 001 will add it to 5000 and this AX is going to be filled with 5001H, right? Like that is going to be executed. That means what? While executing this particular instruction, processor no need to address any internal register or external memory location. Directly the data immediately available in the instruction itself to add to the destination register, and result is going to be stored in the destination, right? Like that, for the accessing of the source data, processor no need to look into the internal register or an external memory location or to the any input device, right? So this is called as the immediate addressing mode. This is called as the immediate addressing mode. And second thing, if you look at this particular one, for example, second thing, for example, register addressing mode. Register addressing mode, right? So register addressing mode, if you look at example, is that move AX comma BX, for example. What is the source here? BX. What is the destination here? Source, so register only, right? These two are internal registers of the processor, right? You know that this is the AX, BX, CX, DX we have internally, right? That is the AL, H, like that we have already seen this particular one, right? AL, H, BL, BH, like that CH, CL and DHDL. If you want to use as a 16-bit like this you need to use, and 8-bit like this you need to use, right? So if you look at this particular instruction, what it has to perform while executing this instruction by the processor, it has to perform like this. Whatever the data present in the BX register need to move to the AX, need to move to the AX, right? AX, right? So from that, what it means, whatever the data in the BX register need to move to the AX, right? To execute this instruction, processor need to be accessed or processor need to be addressed internal register for the source data, for the source data. That is the reason this is called as a register addressing mode. That means what? For the, to get the register data, sorry, source data to add it to the destination data, processor need to be addressed or accessed internal register, that is the BX, according to this particular instruction. That is the reason this mode of addressing is going to be called as the register addressing mode. In the similar way, add AX comma BX. What will happen? BX data is added to the AX. Result is going to be stored in the AX. In the similar way, whatever may be, or AX comma BX. OR logic will take place. BX data is logically OR with AX. Result is going to be stored in the AX. Like that, based on the opcode, it has to perform some operation on the operands. But while performing operation, every time if instruction is such a manner that while executing this instruction, processor is need to move to the source register to get the data for doing this particular operation, that is going to be called as the register addressing mode, right? Register addressing mode, right? In the similar way, any instruction, while executing any instruction, if processor is going to be pointing towards the register to get the source data, or it needs to be access the source register in the source place, or to get the source data, that is called as the register addressing mode. That is called as the register addressing mode. Like that, these are the two addressing modes. We have and other ones are if you see here, other one is direct addressing mode. Direct addressing mode. Direct addressing mode means what? It's addressing mode like this. Microprocessor want to get the data from any memory location in the external memory. Microprocessor as want to read the data from the external memory location to the processor to perform some execution. Right. For the source data, processor need to be address any register or it needs to be access any external memory location. Example is like this. Move AX comma C here. This is the bracket I written. Previously there is no brackets. Here I place brackets. So brackets if I place means I place brackets means right. It is not a immediate addressing mode. This is the direct addressing mode. Previously we have seen move AX comma 5000H directly, right? So in that case 5000 directly move to the AX. But here is while executing this instruction by the processor is going to be performed like this, right? Processor is going to be calculate the external memory location address like this, right? It is going to be address like this. dx into 10 plus 5000 is going to be calculated internal by the microprocessor to get the 20-bit physical address of the external memory location. For example, before execution this particular instruction, ds as a 2000H, right? 2000H. It is going to be calculated 20-bit physical address like this. 2000H plus 10 plus 5000H is going to take place internally, and 20-bit physical address is going to be generated like this. 25,000. This is the 20-bit physical address to select the one external memory location. Whatever the data present in this particular memory location. For example, this is the data present in external memory location, right? That data will move to the AX register after execution of this particular instruction, right? So here after execution of this particular instruction, right, 5000 will not move to the AX, right? Indirectly, directly, 5000 is going to be act like an offset to this particular data segment in the external memory, right? So like this, it's going to be calculated internal by the microprocessor. dx data into 10 plus offset address directly is provided in this particular bracket is going to be added. 20-bit physical address is going to be generated like this. That is going to be sent out through the 20 address lines. That is going to be selected one location in the external data segment. Whatever the data present in this particular data segment selected location, that is going to be moved to the AX register after execution of this particular instruction. As a addressing mode point, we need to understand here like this, right? Directly, immediately this 5000 will not move to the AX, right? This is the way processor is going to be access external location in the data segment, right? While addressing external memory location in the data segment, this whatever we placed in the brackets, that is act like an offset address to generate 20-bit physical address. That 20-bit physical address is going to be addressed one memory location in the external memory, right? This is the way directly addressing one external memory location to get the data into the destination register, right? Source data, how source data is now accessing, right? This is the way it's accessing, right? Source data, right? For the source data, processor is not immediately available source data, or it is not accessing any register, internal register to get the source data to move to the destination, right? In the similar way, add with the carry something. If you write AL comma 5000 H, what will happen? In the similar way, this is going to be calculated the 20-bit physical address, right? The selected register location data is going to be added to the AL, and result is going to be stored in the AL only with carry, right? So in this process, for the source data, right, it is directly accessing the one location like this by calculating the 20-bit physical address, right? You can see other addressing mode here, right? Oh my god. So other addressing mode you can see here. So what are the other addressing modes, right? We have seen immediate addressing mode, direct addressing mode, register addressing mode. So relative register addressing mode or register indirect addressing mode, right? You can see here register indirect addressing mode, register indirect addressing mode, of 8086 microprocessor, right? Example you can see here. These are all similarly as like previous example, indirect addressing mode like that, right? So move AX comma, for example, here I kept SI. Sorry, this is all indirect addressing mode only. This is, you can say that indexed addressing mode also. This is register indirect addressing mode, or you can say that register source indexed mode, right? Source indexed mode. Another example also you can say like this, move DI also, right? Both are going to call as a indexed addressing mode, as well as register indirect addressing mode, alright. The other example also you can write like this, relative addressing mode, like this, move register indirect addressing mode, like this also you can write something like this also, right? So what you need to write here is that, so while executing this particular instruction, how it is going to be access the external memory location. Processor, while executing this particular instruction, how it is going to be accessed, right? So for example, first instruction, if you see here, move AX comma SI, if you write, what will happen? So here, this is the source, bracket is there, means it is external memory location. So processor need to be addressed one external memory location for the source data, right? How it is going to be calculated means 20-bit physical address like this, right? DS into 10 plus SI data. Similarly, right, here previously directly we are placing some data in the brackets, here indirectly one register, that is index register, is providing the data. So for example, before execution of this instruction, internally DS contain, for example, 2000H, and SI will contain 0020H, for example. While executing this particular instruction, this is way it's going to be calculated internal by the processor, right? 2000 into 10 plus 0020H, right? This is how 20,000H plus 0020H, then 2020H, right? So this is going to become 20-bit physical address to address or to access one register in the external memory, right? whatever the data present in this particular register will will move to the AX register, right? So like that, it's going while executing this particular instruction for the source data, processor is going to be internally going to be calculate like this 20-bit physical address, and it's going to point towards the external memory location in the data segment to get the data into the internal register. That means what? For the source data, processor is accessing external memory location by using data present in the source index register as the offset address to calculate the 20-bit physical address. In the similar way, if you look at this particular instruction, second instruction, right, it is going to be calculated 20-bit physical address like this, ds into 10 plus da, and result is 20-bit physical address, right? So for the offset here, whatever the data present in the internal DI register is providing the offset data, right? Like that, it's going to be calculated 20-bit physical address to point the one location. That location data will move to the destination. Right? So like that, it is using index registers. The similar way, here offset is going to be provided with CX register. These are all register indirect only, but if you use SI or DI as an offset provider in the bracket, that is going to call as the indexed addressing mode. Right? If you other addressing mode is based indexed addressing mode. If you look at here, another addressing mode is based indexed addressing mode. Alright, so in this mode, what will happen? Example like this: move AX comma BX into DA. Alright, DA. See here is in two sources. Here is two. One is the base and another one is the index register. Base register and another one is the index register. So bracket is there means previously also we discussed that is one memory location in the external memory. Here how it's going to be calculated 20-bit physical address to get the source data or to access the source data. Right? Here it's going to be calculated like this 20-bit physical address. 20-bit physical address is going to be calculated ds into 10 plus bx data plus da data. It's going to be like this. That means before execution of this particular instruction, if for example ds as a 20,000h and bx is 001h and dis 0020h for example, here it's going to be like this: 2000 into 10 plus internally it's going to be add like this: 0001 plus 0020. So overall it's going to generate 21h. So now this is going to become the 20-bit physical address to select the location, right? Whatever the data is there in that particular selected location, that will move to the AX. This is called as the based indexed addressing mode. Right? In the similar way, we have other addressing modes also. Other addressing modes also. See here, other addressing mode also, based index and relative based index. This example, for example, the seventh one, if you see, move AX comma BX SI, that is 01h for example. This is called as the relative address. Your 20-bit physical address is going to be called like this. For the source data, ds into 10 plus bx plus di plus 01 will take place. Like the 20-bit physical address is going to be generated to select one register among the external memory. That data will move to the AX. This is called as the relative based index addressing mode. Right? So like that we have a 8-bit relative address, or you can have another example like move AX comma BX into DI into not into, in brackets 20 0 to each. Right? In this while executing this instruction, these are all going to be added. That is going to be added as acting like an offset for the data segment, and that 20-bit physical address is going to select one register among the external memory. That data will move to the AX. Right? This is the 16-bit relative based indexed addressing like that. So here you can see that. So overall one by one. Right? So here for example add AX comma 2000H. This is immediate data to execute this instruction. Immediately access the source data to add it to the AX. Here add with carry AX comma 2000 means right. So indirectly it's act like an offset to the data segment, and it's called it 20-bit physical address. From the external memory it's added to the AX along with carry. Right? Register means add with carry AX comma BX data is added to the AX. Right? Register indirect means anyway add with carry, for example AX comma for example BX, it is going to be pointed to the external memory location to get the source data to add it to the AX. In the relative means in the similar way, this relative may be source relative register means you can say that register indirect relative means add with carry AX comma BX into some relative address. Based index means add with carry AX comma SI or DI like this. This one is add with carry AX comma SI DX. Right? So if you observe, except 1 2, this is immediately available. This one is the register for the source data. Internal register is going to be accessed. Remaining all is need to be accessed external memory to get the source data to add to the destination. Right? So like this we need to understand addressing modes. That means simply for the source data how processor is going to be accessing the locations, or how it is addressing location. That's decide the what addressing mode it is using to execute the particular instruction by the processor. Right? Thank you.